Hi everyone, it's Mrs. Bebo. In this video, we're going to continue our lesson on tables of proportional relationships. And in this video, we're specifically going to be looking at identifying the constant of proportionality, which remember we use the variable k to represent. So you're going to see that I'll use k equals a lot, and that's going to help us later on when we actually work with equations of proportional relationships. So as a reminder, two quantities are proportional if the ratios comparing them are equivalent or constant. And again, that constant ratio is called the constant of proportionality. This has the same value as the unit rate. So suppose the creators of a stop motion animation film record at 24 frames per second. The table below shows the number of frames captured over 1, 2, 3, and 4 seconds. So if I take a look at this again, 1 second was 24 frames. And then we have it so that in 48 frames in 2 seconds, we had 72 frames in 3 seconds, and then 96 in the 4 seconds. So if we were to simplify, each of these ratios, right, every single one of these down, you're going to find that they're going to end up being the 24:1. So again, each of these here are going to simplify down to that same ratio of 24 frames per second, 24:1. So that right there is actually our constant of proportionality. So again, a unit rate, so how much per one of something, that is considered a unit rate. So this part in our table here tells us our constant of proportionality, 24:1, or we can just say 24. So what is the unit rate? Well, that's when we actually add those labels, right? So that 24 frames per second, that's going to be our unit rate. So the constant of proportionality, again, is the same thing as our unit rate. So if you know how to find a unit rate, you're going to be able to find that constant of proportionality. So let's take a look at this example here. So we're going to identify the constant of proportionality in this situation where we have a fundraising organization paid $163.80 for 420 wristbands. The cost of the wristbands is proportional to the number bought. We want to know which of the following has the same constant of proportionality. So if we take a look at the original relationship here, this original ratio, $163.80 for 420 wristbands, if we go through and do this division, because we're doing wristbands to the number bought, so the cost of the wristbands to the number bought, we're going to be doing $163.80 divided by 420. So if we just quickly type that into our calculator, we're going to find that that is equal to 39 cents per wristband. I'm just going to put per band. So we want to see which of these has that same basically unit rate, that same constant of proportionality. So we're going to do the same idea except for just with some different numbers, right? So we're going to take $31.20 and we're going to divide that by the 80 wristbands. And so again, if we type that into our calculator, 31.20 divided by 80, we're going to find that that actually ends up being it right away. That's our 39 cents per band. So that is going to have the same constant of proportionality. If we go through and check the next one, so by doing $150.80, and we're going to divide that by 520 wristbands, again finding that unit cost, we're going to find that this one is 29 cents per band. So not the same unit rate, therefore not the same constant of proportionality. Then we can do the same thing with the next one. So same order. So just like we've been talking about in a lot of these videos about proportional relationships, you want to make sure that you are paying attention to the order and keeping that consistent. So for all of these, we're doing cost divided by the number of wristbands. So 126 divided by 315 wristbands is going to give us 40 cents per band, per wristband. And last but not least, we'll be doing $84 divided by the 240. So 84 divided by 240 is going to give us 35 cents per band. So we only had one of these relationships that ended up having the same constant of proportionality. And again, all that means is that you have the same unit rate. So A is our final answer for this example. All right, example 4, we're going to, again, identify the constant of proportionality by, again, finding that unit rate, and then we'll use that to compare our different cyclists here. So the table shows the distance traveled by 3 cyclists during a race. We got Mara, Javier, and Kyle. We're going to rank the cyclists and their corresponding constant of proportionality or unit rate in order from slowest to fastest. So again, they are telling us that they do have a constant of proportionality. So this is a proportional relationship. Mara's is a proportional relationship, Javier's, and so is Kyle's, right? So we don't have to test for that. All we need to do is look for the unit rate, and we're looking at their speed, right? So we're going to rank them from slowest to fastest. So that is miles per hour. What's super nice about this problem is that for Mara, if I look at her table right here, we have 11 miles per 1 hour. That is her constant of proportionality. So I'm going to go ahead and start using that variable k. So k is equal to 11 over 1, or just 11. And again, that's her unit rate. So if we want to write off to the side, the unit rate was 11 miles per hour, right? Her unit rate was 11 miles per hour. If I look at Javier's, I see, again, we have 12 miles per 1 hour. So again, super nice because we don't have to do any extra math here. That is my constant of proportionality, which, remember, that means our unit rate is 12 miles per hour. So K, constant of proportionality, unit rate, same thing. Unit rate's just going to have those labels on it. K, we do not need labels for. Now for Kyle's, we will have to do a little bit of math for, but I think the easiest one to use will be these nice whole numbers here. And so our K value, we're going to do miles divided by hour, so 20 divided by 2, because again, we're keeping that consistent miles per hour. This is going to simplify down to 10. And so the unit rate in this case would be 10 miles per hour, but our value for K is 10. So if we're going to put these in order from slowest to fastest, we're going to rank Kyle as the slowest with the 10 miles per hour, or a value of 10 for K, the constant of proportionality. And then next would be Mara with a speed of 11 miles per hour, or a K value of 11. And then last but not least is Javier. So Javier is the fastest with a speed of 12 miles per hour, or a constant of proportionality of 12. All right, next example. So the tables show the amount that 3 friends earned during a bake sale. We're going to find the unit rate, or again, the constant of proportionality for each friend. We're going to determine who earns the most money per hour. So with this first table, or with any of these tables, kind of like in that previous example, right? I was like, hey, let's try to see if any of these are actually already done, and they're already in a unit rate, right? There's one that's already in the table for us. So with Allie's, we actually have that situation where we have our unit rate already given to us. It's $17 per hour. So we don't have any extra math to do there. And then we can just say that means K is equal to 17. So K, again, doesn't have any labels to it. That's officially how we would write the constant of proportionality, but the unit rate would have the labels. So I'm writing both, as you can see. All right. Then we're going to have to do a little bit more math for. So this isn't too bad. Again, you're just going to have to do some division. You can pick whatever value, because again, they're telling you to find that constant of proportionality, which means all of their relationships are proportional. So then we can just pick the first one. We can do 9 divided by our time here, so 75 hundredths. So again, doing that math there, 9 divided by 75 hundredths, we're going to find that this is $12 per hour. So our value of K is going to be 12. Then we're going to do the same thing for our last persons, right? So with them, we can do $80 divided by 5. Or again, you can pick whatever values you want from that table. They're all going to turn out to be exactly the same. And this ends up being $16 per hour. So K is equal to 16 in this case. So to answer our final question of who earns the most money per hour, that's going to be Allie, because she earns $17 per hour, which is more than anybody else. So that's it for that example. All right, last example here. So a little bit more of a story problem that has a few more steps that we need to take in order to answer the final question. In this question, we're looking at sales tax. So when shopping for school clothes, the table shows the sales tax for various purchase amounts. Is the sales tax proportional to the purchase amount? What is the total cost in dollars for a purchase amount of $84? So first we have to determine whether or not the sales tax is proportional. So we're going to be taking our sales tax and dividing it by the purchase amount. And the reason I know that is because when I look back at this problem, it says the sales tax is that proportional to the purchase amount. That hints at the order in which you're going to divide. So for this first one, we're going to take the 60 cents and divide that by 12. And so when we do that, we're going to find a rate of 500. Then we can go through and do the same thing for each of these different situations to see if they turn out to be the same. So we can take 1 and 20 divided by 24. And then if we do the same thing for each of these, we're going to find that both of these relationships here end up being that 500 as well. And as we were doing, we would be taking this number here, the $1.80, and dividing it by 36. This one we would be $2.40 divided by 48. All of them end up being that 5 cents per dollar that's being added on. So what is the total cost in dollars for a purchase amount of $84? Well, to help us figure that out, that 5 cents per dollar, right? That's essentially what this is, our unit rate here. We can take this 500ths and multiply by our purchase amount of 84. Because again, if this is 500ths per one per dollar, multiplying that out is going to tell us that we're going to end up having a tax amount of $4.20. And so to find out our final answer, we just have to take that $84 and add $4.20 to find that our final answer is $88.20. So since the unit rates are the same, the sales tax is proportional to the purchase amount. So the total cost for a purchase amount of $84 will be, like we said, this $88.20. That's it for this video. Hopefully that helps you understand a little bit more about proportional relationships and calculating the constant of proportionality. Thanks for watching.